Yeah, so let us start. I'm sure yesterday you guys understand gradient descent algorithm. Am I right? We done with that. And the continuation of this session. Bias variance. And the next topic name is a underfitting and overfitting. Underfitting. Let me explain first to overfitting actually. Overfitting, comma, underfitting. Yeah, let's continue. Let me close this. Bias variance and trade-off. The next one is I'm planning for underfitting and overfitting. Order doesn't matter, just to follow the name of the topic actually. Yeah. Before entering into the topic, once can you please read it? These are all topics actually. These are all points. The first one is a these are all ML steps actually. Any ML algorithm should follow the same steps. The first one is a importing libraries. Next one is loading data set. The next one data preparation. Data preparation means being a data scientist or ML engineer, we need to prepare input and output actually. We need to prepare. Client never tell repeating again, client never tell this is the input and this is the output actually. With our knowledge, we need to separate, we need to segregate actually. Once we prepare the data, I mean, once we done the data preparation, the next step is a splitting the data set. Why splitting is required? Why splitting is required? If company have given 100 rows actually, that complete 100 rows we should not use for the training purpose. What we need to do is split the data and 70% and 30%. This 70% train the model, 30% ML algorithm don't know. 30% ML algorithm, what exactly? Don't know. This 30% data is called as a unseen data. What data? Unknown data. Like my father separated 30 images, right? With that 30 images, my father didn't train actually. Then that data is called as a unseen data. What data, sir? Unseen data. Good. Once the splitting the data set is done, then next step is a model creation. Here model creation means all algorithms will come. Step number 5, all algorithms. What are all algorithms you learned till now? Except gradient descent algorithm. What algorithm? When I'm talking about the gradient descent algorithm, in real time, we never implement actually. It's not required. But for every algorithm, the backend support gradient descent algorithm we do have. Once you created a model, I mean, model, algorithm, ML algorithm, these are all very common actually. Let me tell you. Read everyone, what is that one? Model. I hope everyone knows about the chat GPT, right? Chat GPT, whenever you're asking a question, backend, can I show you? First of all, you know chat GPT, right? Please, chat GPT. We'll do one thing. What we'll do, you tell me either it is valid or invalid actually. First of all, print hello world. Is it valid actually? Come on, tell me. Is it valid? Yeah, let me tell you. What is the difference between Google and ChatGPT? Sometimes I feel ChatGPT is really good rather than Google. Rather than what exactly? Google. If you have given this program to Google, even Google don't know what to do. But if you have given this one to ChatGPT, what ChatGPT will do? Patel sir, maybe 1 week I will take workshop actually. I'm planning very soon. Now you can just try to paste your code here actually, and here you can tell this code is wrong. This code is not working, not working. Please fix. Please, what exactly, sir? Fix. Indirectly, I'm asking like a person. I'm asking like what exactly person, and you can paste here actually. Just you can see, and it will fix. That is seriously amazing. What it is telling, it seems to be you have a syntax error, correct? You are missing what exactly? Closing quotation. That is seriously very good actually. But if you copy paste the code over the Google, Google can give 1,000 answers actually. But ChatGPT is giving almost 99% the accurate answers actually. Conclusion of the story, how you are getting, backend model. How you are getting, sir? Model. But here, NLP model. What model? NLP. NLP model means, I mean, after deep learning, NLP I'm going to cover. Natural language processing. The two backend LLM model. What model? Large language models actually. We'll see. So remember one thing, whenever you're talking about the AI or anything, always the model works very well, sir. Model creation. Once model creation is done, next one is a model training. Next one is what exactly? Prediction. Initially, once model created, can somebody talk with me? How much knowledge, sir? Zero knowledge. Model don't know anything about the data. Once the training is done, once what exactly? The training is done, model will come to know knowledge about the data. How many parameters would you have? What is exact output actually? These are all things it will understand. That's why training is required. Once the training is done, then model is ready. What is ready actually? Model is ready. With that model, start doing prediction. Start doing what exactly? Prediction. Yeah. During training, what exactly happening? This one will involve actually. Come on, tell me. ML flow actually. First one is a data. Next one, data frame. Next one, feature engineering if required. Feature engineering if required. Next one is a array. Array to ML algorithm. ML algorithm backend is gradient descent, backbone is cost function. I hope you know what happened exactly we have seen yesterday. Now, if anyone just now joined, actually, we are continuing the session. Please follow the session. Now, the topic name is called as a bias and variance. What is the topic name, sir? Yeah, both are called as errors. Bias, variance actually. Both are called as errors. Both are called as what exactly? Errors. I mean to say that would have a mainly two types of errors, man. Two types of errors. When it comes to machine learning, actually, when it comes to machine learning, there are mainly two types of errors. The first one is a bias error, and the second one is what exactly? Variance error. Second one is what exactly? Variance error. When we are talking about the bias error, what do you mean by bias error? Difference between predicted value and actual value. What is that one, sir? Predicted and actual values. Actual what exactly? Value. This is also called as a cost or residual. Many things we have seen. Good. Even I will tell you what is the meaning of bias. Variance error means sometimes, due to training data set, we will get this error. We will get this error due to due to changes in training data set. Changes in where exactly? Training data set. That word is important. Can you please read the next line actually? We will get this error due to what exactly? Changes in training data. You should know by this time what do you mean by training data set, what do you mean by testing data set actually. I hope you know. Am I right? If you don't know, God's supposed to save you. Are you clear? Good. Keep in mind that we already done. All right, let's move on. Sir, in future, if you are coming in future, remember one thing. Whenever if somebody is talking about something like AI means, Don't think like, backend, just a model. Just what exactly? Model. Model means till now we worked with these are algorithms, right? That is nothing but a model. That is nothing but what exactly? A model will bring the answer. A model will reply the answer. That too with accurate answer. What answer? Keep in mind that AI means group of models. AI means what exactly? Group of model. ChatGPT having lot of models actually. Good. All right. Fine. Let me open the material, please. It's just a 5 minutes theory and one example. Such a funny example actually. You can just try to understand this. Bias is a error or a difference between prediction result and actual result. And variance is the error that occurs due to what exactly? Small changes in a training data set. Now let me tell you. If training is not well, come again. If training is not well, then no doubt at all, testing may fail actually. Am I right or not, sir? Best example, my father started training. I was unable to understand what is going on. Which one is the dog? Which one is the cat? All images are similar actually. Training, I was unable to handle the training very well. Then no doubt at all, testing also will get fail. Which one will fail? Testing also will get fail actually. Remember, the bias and variance provides the information to understand the performance of ML algorithm while doing prediction. Keep in mind that here we are talking about always error actually. Am I right or not, sir? Now let me tell you, error means information to the ML algorithm. Best example, two types of friends. Friend number one, he can tell about your mistakes actually. Mistakes means error. Indirectly, he is giving information, change your behavior, change your nature. Means error. If somebody is telling you are doing mistake, actually, he is providing some information to you. You have to either correct or not. That is actually. Second type of friend, even if you done mistake, actually, he will throw biscuit. Hey man, great, see, you are seriously hero, superhero, something like that. Am I right or not, sir? Good. Keep in mind that. Now read this one. The bias and variance provides what exactly? Information to whom actually? ML algorithm. From that error, ML algorithm will understand, hey, something went wrong with me. Let me change actually. Something went wrong with me in the sense in my prediction, something went wrong. Let me change the prediction. Let me update the parameters, do the prediction, something like this. In supervised learning technique, an algorithm learns a model from what exactly, sir? Yeah, I hope you already know. The goal of any supervised learning algorithm is find the best mapping function, also called as a target function, from output to input actual. Good. Here, I hope I done this role yesterday. Error means some wrong calculation. Error can be small or big actually. Small error can be acceptable and big error should be minimized. We should not leave. If there is a big error, we should not leave actually. Right, good. Prediction error means we made some prediction, but there are some type of errors are existing. Prediction errors for any machine learning algorithm can be divided into two types. The first one is a bias error. Next one is variance error. Hold on. When I say bias, low bias and high bias. Come on, talk with me. When I say bias, low bias and what exactly? High bias. Okay, good. So the bias. Tell me low bias value, low bias actually. Next one is a high bias. I will tell you what do you mean by low bias and high bias. And the next one is a variance. Next one is what exactly? Variance. Exactly. Low variance and next one is what exactly, sir? High variance. High variance actually. High variance. Good. Now, if you wanted to understand these two in a better way, then definitely you need to see one diagram. Yeah, this theory I can cover actually today only. Please, meanwhile, let me give a small explanation for this diagram. Yeah, please observe here. Sir, every ML algorithm, I would like to say, every ML algorithm will try for what it will try, low bias value and what exactly? Low variance value. If any ML algorithm is touching these two, then no doubt at all that model is really very good model actually. That model is what exactly? Really very good model. I mean to say that. Definitely the training started actually. Once the training started, if ML algorithm is reaching these 2 points, if ML algorithm is reaching these 2 points, what is the point actually? First one is a low bias value. Next one is a low variance value. Sir, that algorithm is really very good algorithm. I mean, that algorithm will do accurate predictions. That algorithm will do what exactly? accurate predictions. I mean to say right predictions. Just look at the diagram. Low bias value. Yeah, good. You can keep in mind that bias and variance always be first actually. Left hand side, low bias value, high bias value, and a column wise, low variance value, high variance value. With respect of low bias and low variance, this is exactly the picture. The picture will tells us ML algorithm, the target is really good actually. ML algorithm is really doing nice predictions. The target is exactly red color. Even the prediction is also reaching the red color actually. Now let us take another combination. Low bias with respect to high variance. This is the prediction, but almost somewhat near. I would like to say this is the 100 value, but this is 90 value, 85 value, almost 92, 95, 96, something like this. But sometimes it is okay, good prediction, almost 95, 96, something like this. Come on, talk with me. This combination is called as what exactly? Low bias and what exactly, sir? One more time, man. Low bias and what exactly? High variance. Next one is high bias and what is the next combination? Low variance. Frankly speaking, worst. I mean to say that ML algorithm is not doing a right prediction. Randomly, somewhere one prediction it is right actual. That to no guarantee. That to what exactly? No guarantee. Out of we done 10 prediction, only one prediction is valid actually. And this is out of the box. And high bias and low variance. Sorry. If the yeah, let me tell you. You may ask a question. Daniel, can you guys tell me which model is really good model actually? Which combination is a really good combination? Tell me. Low bias and one more time. Low bias and you may ask a question how to find out. I'm going to show you an example actually. From that example, you will understand low bias value and low variance value. And repeating one more time, this example in real time we no need to do actually, but still if you want, you can calculate actually. Good conclusion of the story. With respect only these four combinations actually, this one also not up to the mark. Yeah, the error is calculated as a difference between predicted value and actual value. Low bias and low variance. This also called as a bias variance and trade-off. So do you know about the trade-off actually? What do you mean by trade-off? Once the model reaches to here, then it will stop training actually. It will stop what exactly, sir? Training. Trade-off means in English, I don't know, but in Telugu, పాట పాడడం అంటారు కదా. They will, I mean, yeah, exactly. Auction actually. Something like that. Someone will start the discussion. If the model reaches exactly this position, trade off. Do you know the trading actually? Exactly. Trade off means this value is really pretty good value. Let's close the discussion. Something like that actually. This is also called as a bias variance trade off. If low bias and low variance, then error is what exactly? Yeah, error is a less. So in this scenario, the model is what exactly? But let me ask you a question. Error never be? Very good. Keep in mind that, right? Error never be zero. Error should be small error is fine. Small error is fine actually. Good. Low bias and high variance combination. Low bias and high variance. Sorry, sir. No. So in this scenario, the model having what exactly? Lower accuracy. I hope you know what do you mean by high accuracy, low accuracy actually. High accuracy means model is really good. Low accuracy means that is not up to the mark model actually. Even high bias and low variance. This one also what exactly, sir? Lower accuracy. High bias and high variance, worst actually. So in this scenario also model having what exactly? Low accuracy. Of course, our model may face any one of this scenario, but if your model is reaching this one, super model actually. And I will read the theory, hold on. And now let me show you one example actually. And let me show you one example. And here you can see output, what you are seeing, sir, talk with me. MSC value. What do you mean by MSC value? Error value. Next one is a bias value. Next one is variance. What is the bias value? 22. What is the variance value? Can I say high bias and low variance? Tell me, sir. Yeah, go actually. And high bias and low variance. High bias and low variance. This is the combination. Model is not up to the mark actually, but still we can use that model. Did you understand? Yeah, good. Let me execute this example. If model is behaving like this, how to get a good prediction? Hyper tuning technique I can cover later actually. Good. Uh, Let me drink water. Online team, are you following? Can I get a response? Online team? Yeah, yeah. So the very first one, first of all, every ML algorithm, every machine learning algorithm, back end bias and variance calculation will be back end process. What processor? Back end process. That's why even sklearn library, sklearn library is not providing any type of function to find out bias value and variance value. Let me repeat one more time. Technically speaking, calculating bias value, variance value, that is not our task actually. That's why sklearn library itself is not providing any function. Library is not at all providing any function to find out these values. To find out what exactly, sir? These values. Did you understand? But what exactly happened? There was a one data scientist. He created one library to calculate bias value and variance value. There was a one data scientist. There was one data scientist. He created one library, sir. He created one library. By using this, we can calculate what exactly, sir? Bias value and what exactly? Variance value. Are you getting what I'm saying? I need a response actually. If you wanted to calculate bias value and variance value, explicitly you need to install one library. That library name is called as a mlextend. What is that library name, sir? mlextend. Conclusion of the story: sklearn library itself, scikit-learn library itself is not providing any function. Why? Because sklearn is talking with you like, Arey boss, that is not your task actually, you don't need to be worried. But indirectly, he created a. Do you wanted to see who created this? Let me show you. He's a really nice author, good person. Hmm. Creator of MLX library, images. Yeah, he's the person, sir. Let me show you. Yeah, 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 exactly. Let me take this one. He had written one ML book that is really very good book actually. Hold on, let me take this. Good. Sebastian, yeah. Machine learning book written by this. Let me just try to search for this. He had written one ML book also. And yeah, exactly. This is the person. No, sir. Yeah, I hope you can see here actually. You can see here. He created this library. He created this library. He had written one ML book also. Seriously, very good book, but not required actually. You don't need to buy. Let's move to the discussion. I hope you know there is a third library. If you wanted to install, how to install, sir? Yeah, pip install ML extend. I hope you already installed actually. Let me just try to reinstall in front of you. Yeah, good. What is the confirmation? Either I installed or not actually. If I already install, you will get always what exactly? Requirement is already satisfied. If it is not installed, it will start collecting the required packages and libraries. Good. And now let me just try to run the example. What exactly I'm trying to explaining, what exactly I'm trying to explaining is, let me tell you. Tell me all ML steps actually. Step number 5 is what exactly? Model. Tell me, sir. Model creation. Step number 6, model training. Okay, sir. During model training, model may face two types of errors. How many types of errors? Two types of errors. First error is a very good. Second error is a variance. Good. Hello, Daniel. Can I see this? Can we see this? Yeah, we can see. Can we see this actually? Can we see this? We can see. That's what. How to see? I'm going to write an example. Did you understand what I'm doing actually? I need a response, man. Good. Let me show you. Why you guys are serious? Saturday I'm taking session. Are you getting angry? Let me drink water, sir. Then let me try for next Saturday also. Just I'm kidding. I will not take. Why I'm taking today means last 2 week, in last week, 2 holidays we got it right. Good. Now get ready. Let us just import the required libraries. We are importing the required libraries. Demo1.py. Good. I hope you already know. We are importing pandas and scalar. Next one is ML extend. I have a question for you. What is this? Function. This one? Class. This one? No doubt in that. Good. Let me just try to move on. And importing libraries is done. Loading the data set. Loading the data set. This one also student scores actually. Student scores. Let us just try to pull the data set. Student scores. Student scores. Not this. Yeah. Kindly please remind me. I need to upload this. Let me add one sentence actually. That sentence should be done. Means two steps are done. Importing libraries is done. Next one is loading data set also done. Come on, come on. Yeah, two steps is done. Move on to the next step actually. Any idea what is this one? Data preparation. Sir, data preparation you can do in a many ways. We are separating input and output actually. But if you are using ILOC, ILOC is a super fast. ILOC is what exactly? I'm repeating one more time. The same step you can do in a many ways. The same step you can do in what exactly? Many ways. But if you are using ILOC, that is a super fast. That is a super fast. You may ask a question, why we need to use? Why? Because we are playing with the big data. This is the data science. This is what exactly? Data science actually. When we are talking, see, just a matter of in the given data set, open this one. And now you can just try to, come on, sir. Good. Please observe here. How many values? 26 or 27? Am I right? 27. But real time, do you think we have a 27 actually? Don't worry. 27 millions also you don't need to be worried actually. 13 crores also you should no need to be worried. Right? That's why ILOC, it works very well. It works very well. There is a reason whenever you are doing this. And next one is, any idea what is this? Splitting the data set. Every step you should have an idea, sir. Please. What is the ratio? 80-20. Yeah, importing the libraries, loading the data set, data preparation, splitting the data set. Then these are all steps. Either it will be anything is pending. Good. Let's move on. Now the next one. Please look at my screen. What is this step? Model creation. Good. We have created a model. But any knowledge actually, initially, once you creating a object to the class is nothing but a creating a model. Creating what exactly, sir? Model actually. They have created in such a way that now execute this example. No knowledge. Now what exactly we are doing, sir? We are calling a function. What is a function? Bias underscore variance underscore decomposition, something like this. What is the first parameter? Model. Good. Second parameter? Sorry. Second parameter is input. Second parameter is what exactly? Input. Input from the training data set. Input from what exactly? Training data set. Third parameter is a y train means output from the training data set. Good. Next one. X test and Y test also we are providing. Good. Testing data set also we are providing. Next one is a loss equals to MSC. Number of rounds equals to 200. Random underscore seed equals to 1 actually. Number of rounds during deep learning you will understand. Random underscore seed equals to 1. We need to provide by default these values, sir. Take this one. And I have a question for you. Can somebody talk with me? You're calling a function. You're calling what exactly? Function. Talk with me. What is this one? Yeah, returning how many values? Three values. Conclusion of the story. A function can return multiple values. A function can return what exactly? Multiple values. Let me just try to write this example in a straight away. Yeah, first parameter is a model, and the second one is a x train, y train, x test, y test. Loss equals to, hello Daniel, can I provide here MSc, MAE? You can provide, sir. Lot of parameters we are providing. Let me run this. Good. Let me print. Let me print these all values. You will understand. MSc value, bias value, variance value. One more point important, sir. What is the point? Order is important. What is important? You should not change the order actually. This is the best example. Can I change the order for this? No, same thing like that. If any function is returning, multiple variables, please order matters. What matters? Order, please. You should not change the order. You should not miss the order. Yeah. What is error value? Error value 25. Bias value is a 22. Variance is a 3. Now I can say variance is a small variance. Bias is what exactly? Big bias actually. Now I would like to say high bias and low variance model. The model what backend created, go back and compare the diagram actually. High bias. Where is the high bias, sir? Here is the high bias. And next one is what exactly? Low variance. What is the low variance actually? This is the low. Yeah, exactly. This is the combination. The model what you created belongs to this combination. Hey, Nirishan, the model works very well. I mean, very well in the sense out of 100, it can give a guarantee, minimum 70 to 80% guarantee. How much guarantee? So it is doing prediction, but not accurate predictions. But not what exactly? Accurate prediction. Now you may have a question. Hello, Daniel. The model what we created, it is having high bias value and low variance value. Am I right? Can I make it, can I convert high bias into what exactly? Low bias, we can do that. We can do that by applying hyperparameter tuning technique. By applying what exactly? Hyperparameter tuning technique. That to here, how much iterations you provided actually? How many rounds? Let us just try to provide 500. We'll see any change is there. It's a kind of some small research. Any changes, sir? But here there is some change. Some change actually. We'll see. Let us provide 5. Let me try. Some change. Did you notice? Some change actually. This error it is okay. Even this one also changed actually. Previously 36. Now what is the value? 11 actually. Like this, if not only this is the one of the this is one of the reason. Not only this one, would have another topic actually. I will tell you later. I can discuss. Take this example. Now let me tell you step by step. I'm sure till now you understand bias and next one is what exactly? Variance. So what do you mean by bias? Bias means what exactly? Error. Bias means what exactly? Error. Sir, it is also called as a once the ML algorithm started training actually, started what exactly? Training. Then back end, ML algorithm will do assumptions. What is that one? Read everyone. One more time. Last time. Good. What do you mean by assumption? When I'm talking about the assumptions, would you have a low assumptions? Next one is good. Low assumptions. Next one is what exactly? High assumptions. High assumptions. First of all, let me tell you what do you mean by assumption actually. Best example. Best example. Let me tell you. At Amirpet. At Amirpet, exactly at during traffic area, Amirpet, exactly center actually, Amirpet center near to Naresheti. Just assuming that there was a traffic, very heavy traffic actually, heavy traffic, heavy traffic. Exactly what happened, sir? At 9 a.m., small accident happened. What happened? Small accident. Don't be worried actually. Nothing happened. Good. Small accident. Then I have a question. During accident, cops are not there, sir. No cops actually. Do you know cops actually? What do you mean by cop? Do you mean teacup actually? No, police people. Assuming that. Good. Then after what exactly? Incident actually, incident, and police came. Who came actually? Police came. Sir, you know what? The nature with the police will be, I like them, especially. Once they entered into the environment actually, what they will do, they will not look like how you are looking actually. They will observe the environment like anything. Even where the small pin falls also, they will understand actually. Police people started assumption. Started what exactly? Let me tell you. At what time accident happened, sir? Talk with me. 9. And police came exactly at 10:30. At what time they came actually? I know why you are laughing. Why? Because always after incident they will come. Am I right or not, sir? Good. Yeah, good. 10:30 they came. Even though they are not available during the premises, during the accident happened actually, once they came at 10:30, the first assumption they will start and they will observe the environment actually. First one is sounds of vehicle coming, sounds of vehicle coming with the sounds of speed. Sounds of what exactly, sir? Speed. Assumption number one. And it is taking right side direction. It is just trying to taking U-turn actually. What it is taking, sir? U-turn. And during that time, the speed is increased. What is increased? Like this, what exactly happened, sir? They will create a lot of assumptions. They will create what exactly? Now let me tell you, these assumptions will helping to the police people to understand the scenario. I'm repeating again. Are you with me? Conclusion of the story, what exactly happened, whenever you started training actually, ML algorithm started doing what exactly? Assumption in the sense, predicted value can be like this, predicted value can be like this, predicted value can be like this. It will started doing assumption actually. Assumptions are helping to do the right predictions. To do what exactly? Right predictions. When I'm talking about the assumption, we'd have a, if it is a small police, a kind of yesterday only he joined actually, he can do small assumptions. He can do what exactly? Small assumption. But there is a police having 10 years of experience. How much experience actually? Like me, hair also turned to white. He will do lot of assumptions. He will do what exactly? Lot of assumptions. Go back and I'm sure you will understand what I explain actually. Hold on. Just try to see. Bias are the simplifying what exactly? Assumptions made by the model to make what exactly the target function easy to learn. Conclusion of the story, ultimately, every ML model will try to do the good prediction. To do the good prediction, backend there is a target function. Which function actually? Target function. For that target function, it will start feeding with all assumption. Hey, function, assumption number 1 is like this, assumption number 2 is like this, assumption number 3 is like this actually. Low bias. Low bias value suggest, I'm sorry, sir, more assumptions. Go back. Here I need to change actually. Yeah. Yeah. Talk with me. Low bias. I hope you already know. When I'm talking about the bias, two types of bias. First one is a low bias, next one, high bias. Talk with me. There are two types of bias. First one is a low bias, next one, high bias. Whenever you are saying about low bias, having what exactly, sir? More assumption. High bias having what exactly? Less assumption. Less assumption. Something like this. Example, low bias machine learning algorithms, decision tree, KNN, SVM, these are all. High bias machine learning algorithm, linear regression, and even, linear LDA. This is almost similar to the linear regression, but we are not using in real time. This is the ML algorithm, sir, but not using in real time. Next one is the logistic regression also. Move on to the next one. Next one is what exactly? Variance. Next one is what exactly? Variance. Good. I hope you already know. Come on, look at me. What do you mean by variance? Any idea? First of all, this error we will get it. We will get it this error. We will get it this error due to changes in training data set. Changes in what exactly? Training data set. Sir, the changes can be two types. Small changes. What exactly? Small changes. Next one is a big changes. I'm repeating again. My father started giving training. My father divided the data 70-30 ratio. Yesterday I have given an example. In between, who joined actually? My brother came. My brother is almost 70. My father started actually. My brother is adding few more images, small changes actually. Sometimes my brother, he may irritate me. 70 plus 120. 70 plus what exactly? 120. Can I say here is a small changes actually? Can I here is what exactly? Big changes. Now read the point one by one. Variance is the error that occurs due to small changes in what exactly? Training data set. The target function is estimated from the training data by ML algorithm. We can expect the algorithm may have some what exactly? Variance. You have to understand, sir. Ideally, it should not change too much from one training data set to other training data set. Yeah, low variance. Low variance value suggests what exactly? Small changes. Repeating again, low variance. Read everyone. Small changes. One more time. Low variance, small changes. And high variance, big changes or lot changes actually. This you know need to focus, sir. Yeah. I hope this point I already told actually. What is the point? Bias variance trade-off. Read everyone. Bias variance trade-off. One more time. Good. The goal of any supervised learning algorithm is achieved to sweet spot. What do you mean by sweet spot actually? Low bias and what exactly? Low variance. I hope we already discussed actually. Any type of ML algorithm will try to achieve that target actually. It may achieve and may not achieve based on the problem statement actually. It means the algorithm should achieve good prediction for performance. Algorithm achieve what exactly? Good prediction for performance. Yeah, sir, these are all not required, frankly speaking. For you guys, not required. These nodes actually. I thought to delete. It's okay. What you can do, till now all examples we executed, right? This example you can apply. This example you can apply actually. You can cross verify what your model is reaching. Indirectly, this diagram is helping. That example is helping to map. You created a which model? We created what type of model actually? Did you understand? Good. So this is something like a any idea? CV value in K-fold cross validation. Do you know CV value? If you don't know, it is okay. Uh, Go back. Sir, there are some different layers. I would like to say this is one boundary, second boundary. I hope you know the archery actually. Yeah. All right. Now let me just try to close this one. Let us enter into the next topic actually. I may leave the session 6:45. 6:45. Sir, that's what I told. That's what I told actually. Bhupesh sir. Please explain this. In machine learning, variance is the amount by which the performance of predictive model changes when it is trained on different subset of training data set actually. Even this one I would like to compare. Did you K-fold cross validation? K-fold what exactly? Cross validation. I hope you have noticed that actually every time the data set is keep on the training data set is changing actually. Did you understand? Even that one also we can tell. I mean to say that if the training data set is keep on changing, then we may get a variance error. We may get what exactly? Variance error. But let me tell you, as I told, sklearn library itself, it is not providing any predefined function. No focus. You no need to focus much actually. Okay. But if you're looking for more example, the best point of contact is the Kaggle actually. All right. What is the regular count? Any idea? 40. 7 members absent. It is okay. All the best for their career. Mhm. Now, the next topic is the next topic. What I told actually, any idea? Underfitting and overfitting. Sir, damn sure interview question, sir. Damn sure interview question. The topic name is called as a underfitting and a overfitting. But first I will explain about the overfitting actually. Then you will understand what is underfitting. Now read everyone, what is the topic name? Underfitting and overfitting. Good. Hold on. Sir, what exactly I need a ML steps, man. I will do copy paste. We don't have a time. I will do copy paste. Take these are all steps and look at this one. Good. Please observe here. Can somebody help me? Step number 5 and step number 6 is really very, very important. Step number 5 and step number 6 is very, very important. That too, this step is very, very important, man. Very, very what exactly important. Once the training is done, once what is done? Training is done. Every ML algorithm tries to generalize well. I will hold on. Tries to generalize well actually. What do you mean by generalize well? Best example, I hope you already know. Can somebody talk with me? My father done the, data set division. Tell me, 70 into 30. 70 data set he is using for what exactly? Training. Sir, 30 data set is called as a, no, testing data set. Am I right? This is also called as a unseen data. What data actually? Also called as a unknown data. Also called as what exactly? Unknown data. Every ML algorithm supposed to do good prediction on unseen data. Every ML algorithm suppose to do good prediction. Good what exactly? Prediction on unseen data. What data actually? Unseen data. This means generalize well. This is having the separate word actually that is called as a generalize well. What do you mean by that? Generalize well actually. And let me read the point. The main goal of every machine learning algorithm model, every ML algorithm model is what exactly, sir? Generalize well. What do you mean by generalize well? Once the model training is done, the model is supposed to do the good prediction over unseen data, unknown data, new data. What is that one? New data. That word also important. New data. Did you understand? Good. I hope you understand. Now, the generalized model provides the suitable output on unknown dataset. This means after providing the training on dataset, it can produce what exactly? The trusted and accurate output actually. Overfitting and underfitting are the two main problems that occurs machine learning because of these ML model performance may impact to reduce. Very, very important. Good, let's move on. During training, I hope you already have seen. I hope you already have seen. What we have seen, it may get a two types of errors. It may get what exactly? Two types of error. First error is a bias. Second one, variance. First error is what exactly? Second error is a again two more problems it may face actually. Take these points during training. Get ready. During training, of course, go back and the seventh step is a prediction. Seventh step is what exactly? Prediction. Now, yes, during training, it may get a two types of error. The first one is a bias. Next one is what exactly? Variant. Sir, again, two more things it may face actually. What is that one? Underfitting and overfitting. What is that one? Underfitting and overfitting. These two also scenarios. Overfitting. ML algorithm may face underfitting scenario and overfitting scenario. First of all, let me explain what do you mean by underfitting and overfitting. Then you will understand why it may face actually. Are you ready? Come on, man. Are you ready? Good. Let me explain. Why I'm keeping here, first of all, these two topics are belongs to during training. You should know. When I'm explaining the topic belongs to out of all these 6, 7th steps actually, which step you should understand. Let me explain. The very first one is, let me explain. I like this concept actually, overfitting first, and next one is the underfitting. Sir, in my exactly eighth standard, go back to my childhood days actually. My teacher name is a Karuna madam. My teacher name is what exactly? Karuna ma'am actually. And she used to teach science. She used to teach what exactly? Science. Good. Keep in mind that we are all, my friend is Vasu. Next one is Nirikshan. Next one is Shanti. Next one is Keshava. Assuming that we are all friends. Total how many members? Four members. Madam started a new topic. Look at me. Come on. Look at me. Madam started topic actually. And when Madam started topic, what exactly happened? Frankly speaking, I didn't understand what is going on. I mean, maybe that day my mood is not well. Otherwise, I don't want to go to the school. But my mother kicked me and she threw me into school actually. Hey, there is a one on YouTube small video, either you have seen or not. A mother will carry the kid actually, throw into the school actually. When I seen that one, I used to memorize my children days actually. Come on, I'm sorry for kidding. Madam started teaching. And frankly speaking, almost the first 5 minutes I understand actually. And after that, what is going on, I didn't understand. Let me tell you, the nature of student will be, if you didn't understand what exactly happened, I have looked at was actually. Am I right or not, sir? Why, any idea? Only me, I'm not understanding, or else he also not understanding. Sir, what exactly happened, when it comes to Vasu? He's rotating his head like, like this actually. Online team, you also look at me, sir. When madam started teaching and Vasu is telling, I understand like this actually. It means what exactly? Karuna madam is understanding, oh, Vasu is really understanding very well. Real understanding very well. What exactly? Understanding. Then the session is done. Then what exactly? The session is done. All guys are like this only. Sir, I would like to say the first one is a training is done. What is done? Yeah, I mean to say that so and so chapter training is done. Chapter training is done. After training, what is the next one? Very good. Now the testing started. What started actually? Testing started. What started, sir? Testing started. Now look at this one. Let me tell you. Karuna teacher having an assumption. What is an assumption, sir? Talk with me. Yeah, very good. Vasu understand the topic very well. Understand what exactly? Topic very well. This is madam assumption. It is okay. Good assumption. Why? Because she's a teacher, right? She also having an assumption by looking at the students actually. But let me tell you, during training, during training, Vasu behaves like he understand everything. He understand what exactly, sir? Everything. Come on, repeat one more time. During training, Vasu behaves like what exactly? He understand everything. But during testing, Vasu got how much marks? 10 out of 100 actually. 10 what exactly? Out of 100 marks actually. Frankly speaking, this is called as a overfitting. This is called as what exactly? Overfitting actually. Let me repeat one more time. Let me repeat one more time. Overfitting. If you wanted to understand about overfitting actually, you should know about the 2 points. You should know about what exactly? 2 points. First one is training period. Next one is testing period. During training, best example, man. Let us take my example only. My father started training. My father started what exactly? Training actually. And he have taken 70 images. For what exactly? Training purpose. Then when my father is telling, dear son, this is the dog, this is the cat, I'm rotating my head like anything. Come on, leave it, leave it. I understand everything I'm telling actually. But next step, I never thought testing is there actually. But during testing, I got a 0 out of 30. 0 out of what exactly? 30. This scenario is called as what exactly? Overfitting. Sometimes your model, it will show good score on the training data set. It will show what exactly, sir? Good score on the training data set. But if you are trying to checking testing, I mean to say that prediction, model will give wrong prediction. Model will give what exactly? Wrong prediction. This is called as a overfitting. This is called as what exactly? Overfitting. Did you understand? I mean to say that training went very well, but the testing went what exactly? Not well. Keep in mind that, right? Online team, did you understand, sir? Yeah, exactly. Somebody is telling, right? Sir, are you scolding me? Just I'm kidding, boss. Overfitting is something like a overconfidence or overaction actual. Very good. Now the next one is what exactly? Any idea? Underfitting. I hope you know. Underfitting means, let me take the same scenario. Let me take the same scenario. This is underfitting. What do you mean by underfitting? Let me tell you. Teacher Karuna madam, when I was in 8th standard actually, chapter training is done. I mean, chapter training is started actually. During this chapter training, there was a person name is what exactly, sir? Talk with me. Nirikshan. During training itself is I'm showing my hands actually. I mean to say that I'm sorry. I didn't understand. What do you mean by underfitting? During training, the model is failing automatically. The model is what exactly? Failing. No doubt at all. Testing also. Exactly. This is called as a underfitting. This is called as what exactly? Underfitting. Come on, let me give a nice explanation for you. Now keep in mind that, let me take ML algorithm. What is this one, sir? ML algorithm. It will try to face two phases actually. The first one is a training phase. What is the first one? Training phase. Next one is a testing phase. Sir, no doubt in that. During training phase, definitely it will get a good score. Definitely it will get what exactly? Good score. Good score actually. During testing, I'm sorry for saying, lesser score. Lesser score. This combination is called as what exactly? Overfitting. What is this one? Overfitting. Did you understand? I need a response, man. Good. Now the next one is what exactly? Underfitting. What is the next one? Underfitting. We can check the score. Today I will show you. Training itself is the lesser score. The training itself is the lesser score. Then no doubt at all. Testing also what exactly? Less score only. This is called as a underfitting. This is called as what exactly? Underfitting. During interview. Explain about overfit model. Overfit what exactly, sir? Model. What do you mean by overfit model? Let me just try to write. During training, the model giving good score. But during testing, the model is not giving good score. This is called as a overfitted model. This is called as what exactly? This is called as overfitted model. Model is overfit actually, overfitted model. And now we need to fix this. Did you understand? Am I right or not, sir? We need to fix this. Means this is a problem. This is what exactly? Problem actually. Good. I mean to say that when Vasu rotate the head actually, Karuna madam understand, Vasu understand very well. But after testing she came across actually, he's overfitting scenario. What scenario? Overfitting scenario. Then Karuna teacher should not leave Vasu actually. And madam will call Vasu. And what she will give any idea? Left and right actual. I mean to say that, Arman, don't be overaction. During training, please, understand the topic very well, something like that. Same thing like that. Whenever you are working in ML engineer, actually, ensure that model may face overfit scenario. What scenario? Then we need to fix, sir. We need to fix. To fix that one, there is a solution. That solution I will tell you. There is a solution. There is solution. First of all, what we'll do, we'll train the model. We'll check the score. We'll test the model. We'll check the score. Then if training score is big, testing score is less. Repeating again, if training score is big, testing score is less, then that is called as a overfitting. I will show you practically. Then we can fix that overfitting. We can fix that overfitting. I will explain that one. Now explain about underfit model. Explain about what exactly? Underfit model. Underfit model. Sir, same thing, sir. During training, the model giving what exactly, sir? Model giving less score. Then by default, testing also less score only. The model also giving what exactly? During training, the model is giving less score. And during testing also, the model giving the less score only. Giving less score. Good. During testing also, the model is giving less score. Less score. Good. Sorry. Good. This is called as a, talk with me, sir. Underfitting. Underfitting. Underfit the model. Underfitting the model. then we need to fix this. There is a solution. Now I will tell you how to fix this. Come on. What is a noise, bias, variance? These are all noise means irrelevant data. Noise means what exactly? Irrelevant data. It reduces the performance of the model. Best example. You may think, sir, why? What is the reason? During training, it is really good. During testing, why it is failing? There may be a chance testing data may be irrelevant data. Best example, my father trained me with cat and dog actually. My father trained me with cat and dog, but testing my brother is taking. Testing data, my brother is showing donkey means actually. What image? I was in confusion state. I mean to say that sometimes the data can be irrelevant data. Data can be what exactly? Irrelevant data. That's why it may face these two scenario. What is the bias? What is variance? You need to walk through. I hope you already done that discussion. Now let me tell you. Overfitting is a scenario where machine learning model cannot generalize well. Cannot generalize what exactly? Well, first of all, what do you mean by generalize? It's supposed to do the good prediction over unseen data, unknown data, new data. Sir, are you with me? I'm repeating one more time. Overfitting is a scenario where machine learning model cannot generalize what exactly? Cannot generalize or fit well or unseen data. The overfit model has what exactly, sir? Low bias and okay. There is a combination. That combination, low bias and high variance, that model is called as a overfitting model. What model? Where to check actually this one? Any idea? We have a diagram. Am I right or not, sir? Come on, talk with me. We have a diagram. There is a combination, low bias, high bias actually, low variance and high variance. Hold on. Let's just try to open that material. Yeah, exactly this. Team, come on, please. I need your attention. Look at this one. Look at this one. Yeah. Come on. See, the overfitted model have the properties. What is the property? Low bias value and what exactly? High variance. Just try to see where is that combination? Low bias and what exactly? Sir, this model is called as a overfitting model. What model? Overfitting actually. I mean to say that the diagram having the meaning actually. This is called as a good fitting model. This is called as what exactly? Good fitted model actually. This is called as what exactly? Overfitting model. Overfitting model. Walk through the diagram. We can avoid overfitting model by using exactly. Whenever you are checking during training phase, it is really good. The score is really good. Testing phase, I mean to say that prediction phase, the score is not good actually. Then you can apply one topic. The topic name is called as a K-fold cross validation. That is a one solution. It is not like that is not only one solution. I have one question. First of all, are you getting? Are you feeling boring actually? No, right? Though it is a theory, but interesting theory. Till now what we done practically, you need to understand these are all theory. One of the solution is called as a k-fold cross validation. What is the solution? K-fold cross validation. That is one solution. Next one is a train with the more data. Train with what exactly? More data. Best example, my father have taken only 70 images, assuming that. Then I was a not that much active guy. Even though 70 images not sufficient for me, then what my father supposed to do? He need to increase the data set. He need to increase what exactly, sir? Best example, let me tell you, more data, more training. I'm repeating one more time. What is that one? More data, more training. If there is a more training, no doubt at all, then definitely the model will give good prediction actually. And removing the features, sometimes we need to identify which feature is really relevant and which feature is really irrelevant. We need to identify. During XE boost, I can cover this point. Repeating one more time, what is this point, sir? Removing features. We need to understand which feature is really performing well, which feature is not performing well. That I can cover during XE boost actually. Next one is a regularization example. What example? Read one more time. Last time. Regularization means ridge regression, lasso regression. Repeating one more time. Regularization means what exactly? Ridge regression, lasso regression. Now, I hope after this one, that is the next topic actually. Where is that one, sir? Any idea? 20? Yeah, exactly. I'm here only. Lasso regression and ridge regression. This is called as a regularization. What is that one, sir? A regularization. I'm repeating one more time. Hello, Daniel. How to fit overfitting problem? How to fix the overfitting problem? These are all solutions. The first solution, you can apply k-fold cross validation. You can apply what exactly? K-fold cross validation. And second one is what exactly? Increase the data set. Increase the training data set. Actually, you can load with more training data set. Next one is a removing the unwanted features, removing irrelevant features. How to remove? By using XGBoost I can cover. Next one is a regularization. Next one is what exactly? Regularization. Next one is the ensemble techniques also. Ensemble somewhere we have seen. Exactly. You know, we have a stacking, ensemble, boosting, stacking, ensemble, boosting. These three type of techniques is called as ensemble actually. Underfitting. I hope you know. Underfitting scenario is what exactly, sir? Any idea? High bias and what exactly? Low variance. Repeating one more time. High bias and what exactly? Low variance. Compare that one. High bias and low variance. Where it is? High bias and sir. Previously, what model we created? That model is called as what exactly? Underfitting model. Am I right? We got this value. Did you notice? I mean to say that high bias. Exactly. The bias value is the high actually. Variance value is what exactly? 3. Then we need to fix this problem. We need to fix this problem. This is called as a, can somebody talk with me? Underfitting model. What model? Underfitting model. Now, if model predicts well on training data set and unseen data set, then it is called as a good fit model. It is called as what exactly? Good fit. Let me tell you. Explain about good fit model. It's simple, sir. Very simple. Talk with me. During, come again. Yeah. Instead of that one, during training, the model is giving good score. What is that one? Good score. And next one is what exactly? Exactly. During testing also, model is giving good score. During testing also, during testing, the model also giving what exactly? Good score. This is called as good fit. This is called as what exactly? Good fit model actually. Do we need to fix this? No fixer. Why? Because the model is really good actually, right? Conclusion of the story. During ML machine learning training, two problems you may face. The first one, overfitting problem. Second one is underfitting problem. Don't think like these two are advantages. These two are problems we need to fix. We need to what exactly, sir? Fix actually. How to fix? I will give a small example. Maybe in another 5 to 10 minutes, I'm going to close the session. Our weekend will start actually. Good. First of all, what do you mean by this? Come on, sir. Talk with me. What do you mean by good fit model? You know, training data set. I mean, once the model is training is done, my father divided the data 70-30. Talk with me. What is the ratio? 70-30. 70 training is done. 30. I don't know those images. That is called as a unseen data. That is called as what exactly? Unseen data, unknown data, new data. If I am really doing performing very well, if I'm really doing performing very well over the 30 images, then that is called as a good model. That is called as what exactly? Good model. Let me take one small general example, sir. Let me take one small general example. What is example? You know, assuming that there are 3 students. Come on, look at me. Look at me. Assuming that there are 3 students, have prepared for mathematics exams. Have prepared for what exactly? Math exam. First student prepared only addition operation and skipped all math operations from the textbook actually. There is a textbook. Textbook name is called as a Chand actually. Assuming that, right? Inside that Chand book, there are some different 10 types of math operations would you have. But the student like only addition operation. What operation? Addition operation, and he prepared only addition operation. Good. Student number 2, you know, prepared all math operations from what exactly? Textbook. The textbook, some A textbook or B textbook or C textbook actually. Repeating again, let me take a 3 students. Let me take what exactly? 3 students. First student, first of all, there is a textbook. Inside the textbook, 10 operations would you have? How many operations? When I say operation, addition, subtraction, multiplication, division, I don't know other actually. Yeah, good. Other operations also would you have? But student like only one operation. What operation? Then he skipped all other thing actually. Student number 1. Student number 2, maybe decent student. He prepared all operations. He prepared what exactly? Like you guys actually. Third type of student. Any idea? What is the third type of student? Yeah, very good, sir. He prepared already X textbook actually. He went to library. He went to what exactly? Library. He asked to librarian one more book actually. What is that book? Arey boss, I already prepared this type of examples in the so and so textbook actually. Can you please give me one more textbook? I'm sure in your academic you may have seen this kind of student actually. Am I right or not, sir? But I have seen my friends, sir. First of all, for me, it is too difficult to prepare what is existing. Sorry for getting man. Few students they will go to library and they will take that too. Textbook is this size actually. How much size are this size actually? Good. Prepared all math operations from the textbook. Yes. Practiced more on new topics from what exactly? Why? Why textbooks also? Now let me tell you. First student, he can answer only for tell me, sir. Addition. Second student, he can answer, which is from what exactly? X textbook. And he can answer to question which are from what exactly? X, Y, Z. Conclusion of the story, assuming that the prescribed text, only X textbook. But if you are, sometimes we may face a question, what I can say, out of syllabus question. What question? Out. Only their students can touch actually. Am I right or not, sir? ML algorithm also same thing like that. ML algorithm is trying to doing prediction on unknown data set. Listen carefully. There are some students, those students can touch out of syllabus question also. What exactly, sir? Not like you. I mean to say that you can write Bahubali movie. Am I right or not, sir? But when it comes to machine learning algorithm, what it will do, it will do prediction on unseen data set. It will do prediction on what exactly? Unseen data set. He can answer to the question which are from what exactly? Textbook XYZ actually. First student, what is this one? Second student is a overfitting. Third student is a good fit. Now, out of all this discussion, remember this one, good fit means even the student is facing some new question, he is supposed to try to attempt actually instead of living. But first student can live, second student can live, third student cannot live actually. Guys, are you getting? Good. Kind of some theory. Practically, I will show you how to fix this underfitting and overfitting by using a lasso regression and ridge regression. Monday session. Monday session I can help actually. All right. Let us close today early actually. Though this is the weekend. Sir, can we also select important features to avoid overfitting actually? Arati, we are doing that. Kusuma, can you please elaborate your question actually? Arati, yes, we are doing by using XeBoost. XeBoost algorithm. XeBoost I am covering. Now you can just try to see. Sir, XeBoost should be existing. Hold on. The last topic should be XeBoost. And let me just try to take and recently batch morning 7:30 a.m. machine learning. Yeah, XeBoost. Kusmo, we are covering. We are covering, boss. All right. So a short session today. Though Saturday, I may not take the complete hours actually, but let me just try to upload. Not only examples, sir. Sometimes understanding theory also really help you to understand the topic actually. Fine. Give me 2 minutes. Let me upload the material very quickly. Five 30. I hope I need to upload 2 topics actually. Yeah. The first one is a bias and variance, including the data set. Come on, 5:30. Machine learning. Now you can bias variance trade-off. Exactly. Sir, I hope I know very well which topic at what time I need to cover. You no need to be worried. why I'm covering the topics. Yesterday only you can understand gradient descent algorithm. I hope you already understand actually. Am I right? But if the gradient descent algorithm I covered a long back actually, sorry, you may not understand. Yes, boss. Let me upload. This one only, right? Sir, once ML is done, other stuff are very easy. Just a matter of few sessions actually. We are almost very near. Mm, come on, let me upload the next topic, which is called. Sorry, man. What is the next topic? Any idea? Underfitting and overfitting. Only running nodes. Now the solutions for underfitting and overfitting, the topic is called as a ridge regression and lasso regression. That is on Sunday, not Sunday, Monday topic. Don't miss Monday session. All right, we done for today's session. Thank you. Happy weekend, boss. Yeah, next Saturday. Maybe I may not take the session. Don't worry. Thank you. Thank you for attending. Yeah.